We're continuing with systems of equations today. We learned how to solve systems of equations by graphing. We are going to take a look at a few a little bit different problems where we are solving a system of equations by graphing. Quick review to solve a system of equations. When we are graphing, we're going to graph each line, and then we're going to try to find where those two lines intersect, where they cross each other. So example 1 asks us to solve this system. We need to solve the given system, and we have y equals negative 2/3 x plus 2 and 2x minus y equals 6. Y equals negative 2/3 x plus 2 and 2x minus y equals 6. The first equation that is given is in slope-intercept form. If it's in slope-intercept form, we can quickly graph by identifying the slope of negative 2/3 and the y-intercept of positive 2. So my y-intercept should be 2. I go to 2 on the y-axis, and my slope is negative 2/3. So I'm going down 2, right 3. And because we're looking for where the lines cross, we're going to graph a bunch more points, down 2, right 3. Got that line there. If that were to continue, I can also go up 2, left 3. Up 2, left 3. All those points fall on the same line. And we graph our first line. Those are all the points that make this first equation true. The second equation is in standard form. When it's in standard form, we have two options. We can either find the x-intercept and the y-intercept, or we can change to slope-intercept form. Either way is perfectly acceptable. I would generally try to find the x and the y-intercepts first, and then if either of those are fractions, I would do it the other way where I change to slope-intercept form. So an x-intercept, we plug in 0 for y. To get the x-intercept, we plug in 0 for y. So it's just going to say 2x equals 6. 2x minus 0. We don't have to write the minus 0. Solving for x, I get x equals 3. My x-intercept is 3. My y-intercept, I plug in 0 for x. So it says negative y equals 6. It's the same as negative 1y. And dividing both sides by negative 1, I get y equals negative 6. My y-intercept is negative 6. I have my x-intercept and my y-intercept. When I draw this line in, I'm going to be able to see right where they cross. It's going to be right there. So I don't need to worry about finding any additional points. There is our second line. We found where the lines cross right here. That is the intersection point. That should give us our solution. Our solution has an x value of 3 and a y value of 0. 3, 0. Example 2, same type of problem. We are asked to solve the given system of equations. Our first equation says y equals 1/2 x minus 3. And then we've got 2x minus 4y equals negative 8. Y equals 1/2 x minus 3. 2x minus 4y equals negative 8. Our first equation has a y-intercept of negative 3 and a slope of 1/2. Rise over run. Rise is 1, run is 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. And let's go down 1, left 2 to continue getting points on that same line. We have plenty of points to draw a really good line. The second equation, again, it's in standard form. Let's find the x and the y-intercept. We're going to do it the same way we did the previous problem. We get the x-intercept by plugging 0 in for y. If I put in 0 in for y, I get 2x equals -8. Dividing both sides by 2, I get x equals -4. The y-intercept we can get by putting 0 in for our x. If I put 0 in for x, my equation says -4y equals -8. Divide by -4, we get y equals 2. We have 2 points. That'd be enough to draw a pretty good line. If we do need additional points, you can check the slope. To go from here to here, my slope is up 2 over 4. So I could go up 2 over 4 more. If I needed more, if I had a bigger graph, I could go down 2 and left 4 to get another point over here. And we graph this line. Remember, we're trying to find where the 2 lines cross. It appears as though we have parallel lines. Our lines do not appear to cross. This slope we said was up 1 over 2. This slope is up 2 over 4. And then 2 over 4 I can reduce. I can divide those both by 2. Notice my slopes are the same. Same slope, parallel lines. Parallel lines never cross. We're trying to find the intersection point. If they don't cross, we still need to write what our solution is, but it just so happens that we do not have a solution. We should state that there is no solution. There are no values of x and y that will make both of these equations true. Example 3, 8x minus 2y equals 8, and y equals 4x minus 4. 8x minus 2y equals 8, y equals 4x minus 4. First one's in standard form. We've done these a few times now, a couple, I guess. This will be the third. Let's find the x-intercept and the y-intercept. X-intercept, I put in 0 for y. 8x equals 8. Divide both sides by 8, I get an x-intercept of 1. I'm still working with this first equation. I'm finding my y-intercept. If I put in 0 for x, I get -2y equals 8. Put in 0 for x, -2y equals 8. Divide both sides by -2. And I get y equals -4. Again, 2 points isn't a bad graph. Another point or 2 would be good. We can use this slope, 1, 2, 3, 4 over 1. Continue doing that, up 4 over 1. And we have filled up the whole graph, so we can draw our line in. Now we do the second line. The second line has a y-intercept of -4 and a slope of 4. It is in slope-intercept form. Y equals mx plus b. So y equals, we're using slope-intercept form. My y-intercept is -4, and my slope is 4. Rise over run. Up 4 over 1. Up 4 over 1. And if I graph this line in, notice this line lines up right on top of the other line. Both lines are the same. Well, if I have one line right on top of the other one, those two lines intersect at all of their points. If that's the case, we state that there are infinitely many solutions. Example 4 is the final one for today. Again, we are asked to solve the system of equations. We are given 3x plus 5y equals negative 10 and y equals negative x. 3x plus 5y equals negative 10, y equals negative x. Right away, we notice that this first equation is in standard form. My x and y are on the same side. So let's start to get the x-intercept and the y-intercept. X-intercept, if I put in 0 for y, it says 3x equals negative 10. And I divide both sides by 3. And I get x equals negative 10 divided by 3. Well, that doesn't come out even. It also doesn't reduce. It's negative 3 1/3, or really just negative 10 over 3. That's not going to be easy to graph. Negative 3 1/3, we could approximate where it is, but it's going to be tough to get a precise graph with a fraction as the x-intercept. So when that's the case, getting the x and the y-intercept, that's not the best method anymore. So instead, this is where we should change to slope-intercept form. So I'm going to rewrite that equation down here. 3x plus 5y equals negative 10. And we're going to change it so that the equation says y equals something. Y equals mx plus b. Start by subtracting 3x from both sides. Positive 5y comes straight down equals negative 3x minus 10. To solve for y, we need to divide both sides by 5. So I get y equals negative 3 divided by 5x. And then I've got negative divided by positive minus 10 divided by 5. So just did 3 divided by 5, 10 divided by 5. And then 10 divided by 5 is 2. So 10 divided by 5, let's rewrite that as 2. Now it's in slope-intercept form. If it's in slope-intercept form, it's much easier to graph. Y-intercept is negative 2. Slope is down 3 over 5. Rise over run. Down 3 over 5. I can get another point by going up 3, left 5. Let's draw our line in. So that first equation took a minute to take care of. The second one's a little easier. Y equals negative x. It says y equals, so it is in slope-intercept form. My slope is negative 1. And my y-intercept, if there's nothing added to the end, that's the same thing as adding 0. That's the same as plus 0. So my y-intercept is 0. And my slope is negative 1. Down 1 over 1. Down 1 over 1. Over 1, and so on. And we found where those two lines intersect each other. If you don't find the intersection on this side, make sure you kind of backtrack and go over here to try to find it over here somewhere. And we should be able to graph our line in. And then finally find our intersection point right here at the point 5, -5. That is it for today's notes. That was solving systems of equations by graphing. We will continue with systems of equations next class. We will solve them by substitution. Take care.